So again, graphing linear equations. We have a couple things that we need to talk about. There are three different formulas that we need to talk about when graphing, but then we also need to talk about slope. So slope, first off, let's start with that today. Slope. Slope, sometimes referred to as our rate of change, is represented by an M. Now, can somebody tell me one way that they know to refer to slope? Rise or run. Probably the most popular answer, right? Rise or run. Rise meaning changing your y value, going up and down. Run meaning changing your x value, going from left to right. So another way that you'll sometimes see slope in is change in y over change in x. Again, that little triangle symbol, that's our symbol for change. It's a delta symbol. It means change. So how do you find change in y and change in x? What are you actually doing if you're asked to find the change? What operation would you end up doing? You started saying it. Subtraction. We're finding the difference. Right? When we find the change, we're finding the difference. We're going to subtract. So there's an equation for slope, which is y2 minus y1 over x2 minus x1. So slope, we have a couple different ways of referring to it. Again, rise or run, change in y over change in x, or you can actually use your equation if you're given 2 points, y2 minus y1 over x2 minus x1. All those will give you the same outcome. Now, when we talk about word problems, we're not going to do a lot with word problems in here, but if we were talking about slope in terms of a word problem, that's where you also refer to it as the rate of change, because you're talking about the change in y compared to your x value while it's increasing from left to right. So, there are 4 different types of slope. So, 4 types of slope. I'm just going to do 4 of the mini graphs here. First type of slope, if you're going up from left to right, what would that be? What type of slope is that? So if it's increasing from left to right, we refer to that as a positive slope. Whereas if it was decreasing from left to right, so going down from left to right, that'd be negative. We could also have no change from left to right. So if it just stayed flat, well, if it's not changing, it's neither positive nor negative, it's what? There is a slope. Because it's still going from left to right. But what's the change from left to right? Is it changing at all? No. So that's where we could say it's a zero slope. It's not changing, so it's zero. There's zero change from left to right. If you're to think about in terms of our equation over here, well, if you picked a point over here and picked another point over here, what value doesn't actually change? Is it the x or the y? Well, the x continues to change from left to right, but the y value, the up and down value, that's not changing there. So if you were to plug the same y value in twice, say this was at maybe 2, right? So we had 2 in for both those numbers. 2 minus 2 would just be 0, and 0 divided by anything is just 0. Now, the last type of slope is if we don't have a change from left to right, it's just a vertical change instead, going straight up and down. So we have a vertical line. What type of slope is that? So if I ask, what's the change from left to right? How would you define the change from left to right? Can you define the change from left to right? No. So what do you call that slope? It's not zero because there's nothing to even compare it to, right? So this one's the one that's undefined. That's when we have an undefined slope. Because again, it's not changing from left to right. We don't have a left and right. And if you compared this with your equation, here the y values are changing, but the x's aren't changing. So say this was the same x value. You put the same two x values in the bottom and subtracted them, you get 0 on the bottom. Can you have 0 on the bottom of a fraction? No. You can't divide by 0. So that's another reason why it's undefined. So let's take a look at two problems real quick. So we're going to find slope on two graphs, all right? So I got 2 points on this one. You got a point at -2, -1, and a point at 2, 0. And then for my second graph, I have a point down here at -1, -1, and a point up at 1, 2. Not the straightest line in the world, but so now I want to find my slope. How do we find slope on that first graph? So you said up. Are you going up 2? Go down 2. Wait, you're looking at this graph, right? Okay. So on this graph. So if I'm going from this point to that point, first, what's the change in your y? I saw you put a 1 up by your finger there. All right, so we went up 1 unit. All right, this is just a change of 1. And then we got to figure out how far we're going over. So how many units are we going over there? 4. So you could get your slope one of two ways. Here, I'm just looking at the graph. I can see that there's a change of up 1 and over 4. So I could go straight to my final answer here and say it's a slope of 1 over 4, which means I'm going up 1 and over 4. The other thing that you could have done is I gave you the 2 points, right? If I give you the coordinate points, you could also plug into your equation that we had up here. So your equation was y2 minus y1 over x2 minus x1. Now, it doesn't matter which one you call y1 and x1 and y2 and x2. Not really. All right. But what you do have to make sure you keep in common is, say I put this coordinate first up here. So I put the 0 first for my y. Well, then I'd have to put this 2 first when it comes to my x's. I have to make sure I go in the same order for both the top and the bottom of that equation. So I'm going to say that the 0 will be my y2 and the 2 will be my x2. And I'm going to subtract from that -1 and -2. If you do that, 0 minus -1, well, that really becomes plus a positive. So that's a positive 1. And then same thing here. 2 minus -2, that becomes plus a positive. So we're adding 2, and we get 4. So we get 1/4. Same thing that we had down here. So in 2 different ways, you get the same answer. Now, on number 5. Oh, I just realized this. I numbered that 4 and 5. In my first class, I went backward. So I did the slope part second and encountered some problems. So I'm doing the slope first in this class. So on my class last period, it was examples 4 and 5 because we had 3 other examples before it. So I'm going to go ahead and change that though because that's kind of confusing. So this is really example 1 and 2 now. So, all right. Anyway, on this one, how many units are we going up from this point to that point? So what's the change here? 3. So I went up 3. How many units did I go over? 2. So my slope here can be 3 over 2. Now, what would happen if I had said that I went the other way? I went from this point to this point. Would it still work out? Let's see. So if I went, I'll use a different color to represent this. If I went down and back, what's my change here? If I went from this point to that point. Now I'm going down, I'm going a -3. On here, I went backwards, so I'm going a -2. But if I did -3 over -2, what happens if we have 2 negatives? They turn positive, so it's still 3 over 2. It's still the same answer. And again, that's why it doesn't matter when you go to plug in the equation which point you use first in your equation, because no matter if you're going from left to right or from right to left, it's going to come out to the same value. You might end up with 2 positives, or 2 negatives, and it has to be changed to positive in the end, but you'll get the same value. So if I did this as an equation, I'm going to use this point first and then that point just to show. So I have -1 and -1 to start off my equation. And I subtract. I got the 2 and the 1 from the first one. -1 minus 2, -3. -1 minus 1, -2. And again, just like I had happen down here in the orange, we get positive 3 over 2. So no matter what you do, you get the same slope. So now that we've talked all about slope, let's go ahead and talk about our different equations that we have. So there are 3 different equations when it comes to graphing a line. Can somebody tell me one format that we have? Y equals mx plus b. All right? That's probably the most popular form to graph anything in, right? Y equals mx plus b. Do you know what that one's called? Not y-intercept, slope-intercept. All right, you're close. So slope-intercept. Again, it's the most common form to graph in. And it's called slope-intercept form because it tells you two things. It tells you the slope, which is represented by m, and it tells you the intercept. Which intercept does it tell you? Not the x, the y, yeah. So b represents the y-intercept. It'll be in the form of 0, comma b. Okay. Does anybody know another format? The other two aren't used as much. What about, here, I'll write it out and see if you can name this one. AX plus BY equals C. Anybody know what that one's called? No? That one's called standard form. There's a third form as well. Probably everybody's least favorite. It is y minus y1 equals m times parentheses x minus x1. Now, I don't know why people tend to not like this one, because it's actually a very easy formula to use. Anybody know what this one's called? Yeah, point slope. So this is point slope form. All right. And it's called point slope form because you're given a point and the slope. The x1 and the y1 represent a point on the line. So x1, comma, y1 is a point on the line. And then the m, just like in the other equation, represents our slope. Now, the one that I put in the middle, standard form, it does not have values that we can just pull out of it like these other two. So slope-intercept form and point slope form, you can identify things just by looking at your equation. Here, you can identify your slope and your y-intercept right away. Here, you can identify a point and your slope right away. But in standard form, you can't just look at it and be like, hey, that's the value that I need to put on my graph. You have to do a little bit of work in standard form. Now, when do we use standard form? So let me move this up a little bit. We use standard form to find x and y intercepts when we're graphing. All right? It's an easy format to identify x and y intercepts. So I'm going to put underneath this one, used to find x and y intercepts. So again, those are three formats. Yes? Question? Actually, I had somebody else ask. All right. So I'm going to do an example with each of these. All right. Make sure you have those copied down first. Just make sure you don't hold it too close. All right, so three examples. First example. So this will be, change my numbering. So this will be example 3 now. Actually, let me put some instructions first. Graph the following. So number 3. So the equation will be y equals negative 2x plus 4 negative 2x plus 4. And then for the next one, so number 4, this one will be 2x minus 3y equals 6. And then the fifth and final example will be y minus 3 equals 1/2 x plus 1. So, now again, 3 different equations, 3 different formats. First one is in slope-intercept form. Second one is in standard form. And the last one's in point-slope form. So we're going to look at graphing one from each type. Now, we need an x and y axis first to start this off. So, on the first one, you do need at least 4 units above your x axis. So, 1, 2, right here. Just give me my x and y. The others I'm going to draw just more uniform. If you had 3 units in both directions for this one, that would be fine. Again, x-axis, y-axis. And the last one will be up a little higher. I'll let you know now. So, kind of like on the first graph, I'm going to leave a little more room up top. X, this will be my y. So now, first, going through, all right, line number 3. All right. Using slope-intercept form, I can identify 2 things. What 2 things can we identify right now? We should be able to identify, again, in slope-intercept form, should be able to identify our slope and our y-intercept. Which one do we need to start with? The 4, all right? The 4 is our y-intercept. The reason why we have to start with that 4 is because we need a starting point. The slope doesn't give us a point on the graph to start from. So we need to start with a point. So here we're going to use the y-intercept, and the y-intercept on this one is 4. So we're going to go on our y-axis here and go up 4. 1, 2, 3, 4. So I have a point at 0, 4. Once we have a starting point, then we can use our slope. So we're going to go down 2. And over, well, I don't have a number on the bottom. How many units do I go over? 1. So down 2 over 1. Again, you read it like it's a fraction. So if it doesn't have a number on the bottom, if it's a whole number, it's just over 1. So down 2 over 1. Now, if you want to draw a really straight line, you might want to graph more than just 2 points. 2 is all you really need. But again, I could use my slope again and find another point. So go down 2 and over 1 again. And you can graph as many points as you need to draw a straight line. Right. So that would be my graph. Now, on number 4, again, I can't just look at that one. I have to plug in some values. So in order to find an x and y intercept, what do you plug in for the x and y's? So if you're looking for an x intercept, what's your y value have to be? along the y-axis, your x's are zeros. Along the x-axis, your y value is 0. So we're going to plug 0 in for one of these two variables and then solve. And that'll give us either x or y. So if I want to find, for example, the x-axis, I could go ahead and plug 0 in for y. And if I do that, this whole thing would cancel out because 0 times any number is just 0. So now I have 2x equals 6. Well, I need to solve. That's what we did last week, right? We solved. So how do I get this 2 over to the other side? Divide. So 6 divided by 2 is 3. So my x value will be 3. So on my x-axis, I have a point at 3, 0. Then on my y-axis, I'm going to plug 0 in for x and do the exact opposite. So I plug 0 in there. Now I'm left with negative 3y. I have to solve for y. Again, we're going to use division. Divide off the negative 3. 6 divided by negative 3 is negative 2. So I have a point down here. So that's at 0, negative 2. All you need is 2 points to graph it. Again, 2 points will form a line. So that would be my graph. On 5, this one's called point slope form. Again, could I start with the slope? No. Again, you can't ever start with slope. You have to find a point first because you have to have a point to go from in order to use your slope. So this is the tricky one. I think this is why people tend not to like this one. It's because if you look at the original equation, the symbols that come before the x and the y values are negatives. Somebody grab that door for me. So since the original values up here are negatives, when we pull them out of the equation, that means we have to pull them out as the opposite value. So if we're looking for our coordinate, our xy coordinate here, well, this is our x value. It looks like it's a positive 1, but is it a positive 1? No, it's a negative 1. Because again, in order to get a positive value there, that means that they would have had to subtract a negative 1. So it's actually a negative. So we have a negative 1 for our y value. Sorry, x value. For our y value, we have y minus 3. Well, again, it looks like negative 3, but is it a negative? It's actually a positive. Again, we got to switch the sign when we take it out. So the y value will be a positive 3. So we have an x value that's a negative 1, and y value that's a positive 3. So negative 1, positive 3. So that's our starting point. Now, the slope that we have is 1/2, 1 over 2. So from this point, I'm going to go where? What direction? Is it down? Oh, I heard up as well. So this one, both of these are positive, right? So I could say up 1 and over 2 to the right. Now, could I have went down? I could have, but if I go the opposite direction, I need to go down 1 and back 2. Now, that's still a positive slope. Because if I went down and back, those are 2 negatives, and 2 negatives make positive. So sometimes it'll help to go both directions in order to make a nice straight line. So, just to recap, underneath these I'm going to write out what we just did. Alright? So, this will be the last part of the notes for today. Alright? So, on the first one, the first thing that you had to graph was your b value, your y-intercept. So, we graphed b. B was at 4. How do we graph that? Well, that would be 0, 4. That's how you graph your b value. Then from there, we used our slope. What was our slope? Our slope was negative 2, which is the same thing as saying negative 2 over 1. So that means that we're going down 2 and to the right 1. Number 4, you had to graph your x and y intercepts. So we had our x-intercept and we have our y-intercept. For the x-intercept, we plugged 0 in for the y value. So we took our equation. Now, I didn't show these steps the first time because you don't really have to show these because it's easy just to use a pen, cover up the one value because, again, that's getting canceled out. And then we'd be dividing by 2 because we get 2x equals 6. So 2x equals 6. Divide by 2. And x equals 3. And that gives us a point at x is 3, y is 0. For the y-intercept, we did the opposite. We plugged 0 in for x. So 2 times 0 minus 3y equals 6. Again, that canceled out. Just gave us the negative 3y equals 6. Divided by negative 3. And y was negative 2. Again, that gives us its own coordinate point. We plugged in 0 originally for x, and our y value is negative 2. So again, that's where we got those 2 points, the graph, and then we drew our line. And then on the last one, we have to start with a point. So graph x1, y1, which in this case is negative 1, 3, because when we pull them out of the equation, we have to change the signs. And then we use the slope. And the slope here was 1/2, which meant we're going up 1 and to the right 2. Any questions on what we did today? All right. So I'm going to stop there for today, and then tomorrow we still have to look at writing an equation when given a graph, and then we'll also do some practice tomorrow as well. All right. So tomorrow we'll finish up the last piece, and then we'll do some practice, and then later this week we'll also be doing this with our inequalities.